Hey guys, Ms. Peterson here, and welcome to a chemistry lecture all about Bohr models. In this lecture, we're going to be going over energy levels and valence electrons and how to use the periodic table as a model to draw our Bohr models. So let's get started. So what do the rows on the periodic tell you? Well, the rows on the periodic table are called families or periods, and they tell you the number of energy levels that an atom has. Now, energy levels is really the average distance away from the nucleus that an electron is. So the first energy level, n equals 1, is going to be closest to the nucleus. N equals 2, a little farther away, 3 and 4. So the elements that are at the top of the periodic table, like hydrogen and helium, only have one energy level around their nucleus, where something like potassium and calcium are in that 1, 2, 3, 4th row, would have 4 energy levels. So that's what it is, that average distance away from the nucleus. If you have more energy levels, you're going to be a bigger atom, you have a bigger radius, because you got more layers of electrons. And if you have less energy levels, you're going to be a smaller atom. Okay, cool? Okay, cool. So what about let's do some examples. So how many energy levels would an atom of carbon have? Well, carbon is right here on the periodic table. So your instinct might be to say 1 because it looks like it's in the first row. But remember, hydrogen and helium are the ones in the first row. So an atom of carbon would have 2 energy levels. Okay. What about oxygen? It's right next to carbon, so you're right. 2 energy levels. Calcium, right there on the periodic table. It's in the 4th row, so 4 energy levels. And last but not least, aluminum, right here on the periodic table. It's in the 1, 2, 3rd row. So atoms of aluminum have 3 energy levels. Okay, cool? Okay, cool. What about the columns? If there's a pattern in the rows, there's going to be a pattern in the columns. So the columns are called groups, and they tell you the number of valence electrons that an atom has. Now, this is one of our new vocabulary words. Valence electrons are going to be electrons that are in the outermost energy level, okay? And this is really important because the electrons in the outermost energy level are the ones on the outside of the atom. They're the ones that determine how that atom interacts with the world around it, okay? It is the valence electrons that determine its reactivity. So atoms with the same number of valence electrons in the same family, in the same group on the periodic table have very similar properties. Now, the formula for valence electrons isn't quite as straightforward as the one for energy levels, okay? For groups 1 and 2 it is. If you're in group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, you got 1 valence electron. If you're an alkaline earth metal, that's the group 2 elements, okay, you have 2 valence electrons. But then we get into the transition metals, okay, this group 3 through 12 here. Now, I have a very old periodic table that has an old naming system on it. Your periodic table likely says groups 1 through 12 on it. And those have electrons in d orbitals, which are kind of funky. We'll get into that more later, but I'm not going to ask you about the valence electrons in there. They're kind of complicated. It's a little funky. So we skip the middle chunk. We skip groups 3 through 12. We skip the transition metals. I'm never going to ask you about valence electrons of the transition metals. So then we're over here. This is group 13, and they have 3 valence electrons. Group 14 has 4, 15 has 5, 16, 6, 17, 7, and group 18, 8. Okay, so for groups 13 through 18, you have to subtract 10 to get its number of valence electrons. Okay, so let's practice with some examples. How many valence electrons would an atom of sodium have? Sodium is Na on the periodic table. It's in group 1, so it's got 1 valence electron. Okay, pretty straightforward. What about oxygen? So it's in group 16 on the periodic table. Group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so remember we skipped those middle ones, so group 16 has 6 valence electrons. What about neon? Neon is in the column 18, which are the noble gases. Okay, they are especially stable because of their 8 valence electrons. Okay, 8 valence electrons is the optimum amount for stability because you'll have a full s and a full p orbital in your outermost valence shell. Okay, and let's do one more example. What about magnesium? Okay, it's in column 2. We can't subtract 10 from 2, so we have 2 valence electrons. Okay. Now, in order to get this to sink into your brain, to remember it, I want us to be able to remember the groups and the periods. So the way that you can remember this, okay, is you go groups and periods, groups and periods, and valence electrons and energy levels, and valence electrons and energy levels, okay? Do that dance in your head, say the words out loud, and I promise it'll create a link in your brain and help you remember it, okay? Do it with me one more time. We got groups and periods, and groups and periods, and valence electrons and energy levels, and valence electrons and energy levels. Yeah? Okay, cool. So, how, then, do we use this information about our valence electrons and our energy levels to draw Bohr models? So, Bohr models focus on representing the electrons in their appropriate energy levels. Okay, here's a Bohr model for sodium. Sodium is in the 3rd row, so it has 3 layers of electrons, and it has 1 valence electron. So, you can see 1 electron in that 3rd shell. To draw a Bohr model, the first thing you need to do is find the total number of electrons that the atom has. So if it's a neutral atom, it's going to be equal to the number of protons. Sodium is number 11 on the periodic table, so neutral atoms of sodium have 11 protons. Once you know neutral atoms of sodium have 11 protons and 11 electrons. So with those 11 electrons, how do we decide where to put them? Well, you start placing them on the energy level closest to the nucleus, and you spread them out around the atom as you go. But each energy level can only fit a certain number of electrons. The first energy level can only fit 2 electrons. The second energy level can fit 8 electrons. The third energy level can fit 18, and the fourth can fit 32, okay? Which makes sense. As you go bigger, the electrons have more room, so you can fit more of them. Electrons are negative. They repel each other. They want to spread out. If you give them more room to spread out, there can be more of them in that area. Okay, so let's go ahead and do some examples. Oh, also, one last thing. Sometimes the symbol, like in this example for sodium, or the amount of positive charge of the protons will be placed in the middle, just to give it some extra information, but not always. The classic Bohr model just has a dot in the middle and shows the electrons. So let's practice. Starting with good old oxygen. So oxygen is number 8 on the periodic table, meaning it has 8 electrons. Okay. Now, it's also in the 2nd row, so I know it's going to have 2 energy levels. So I'm just going to start with that. 1, 2. Now, 2 electrons fit on the first energy level. 1, 2. And then since the atom has 8 electrons, I have 6 more electrons to place. 8 minus 2 is 6. So I go 1, 2, 3, 4, 5, 6. Okay. It doesn't really matter where you put the electrons, but I tend to spread them out like far away from each other and kind of segment them out, okay? And then you can always check. We got 6 electrons in our outermost energy level, or 6 valence electrons. Oxygen is in group 16, so it should have 6 valence electrons. Okay? Let's try a slightly harder one. We got aluminum. Right here, it's number 13. So we got 13 electrons that we're going to be placing. Now, like I said, 2 fit on the innermost circle. 8 fit on the second circle. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so far in my structure, I have a total of 10 electrons, but I have 13. So I'm going to place 1, 2, 3. I don't know why that energy level was so big, but I got 3 more electrons, 10 electrons in my structure. It's in group 13, so it should have 3 valence electrons. Okay. And that's how we can use the periodic table to draw Bohr models. Okay, cool. Okay, cool. Also, just a little side note, this method will really only work up through number 12 magnesium. Once we get into that 4th row, we have to change the way that we order the electrons. And we'll get deeper into that when we talk about electron configurations in our next lecture. Okay, cool. Okay, cool.